Good evening, class. My name is Jacob, and my team and I will be taking you through the exciting world of 3D printing and the benefits that it has for the medical industry. Now, I'm sure some of you have probably been wondering, how does 3D printing work? Well, 3D printing works through the additive manufacturing, or AM for short, which refers to the successive addition of thin layers between 60 to 180 microns in order to create a project. So think of a house, and that you have your foundation. From there, you build upon slowly up until it's complete. And that's pretty much what 3D printing is. Now, my team and I want to explore that further, both with supplies and organs and other benefits within the medical industry. Now, enough about that. Let me turn it over to Sasha to let you know how the technology works in full effect.
Hello everyone, this is Shasha Li. I'm going to talk about how does 3D printing works and how it is different from what came before it. First, we are going to talk about working process. You start by designing a 3D object on an ordinary PC, connected to a 3D printer. The 3D printing process turns a whole object into thousands of tiny little slices, and then make it from the bottom up, slice by slice. Those tiny layers stick together to form a solid object. Each layer can be very complex, meaning 3D printers can create moving parts like wheels as part of the same object. You can print a whole medical device from the machine without using any tools. How it is different from what came before it. In our traditional manufacturing, it produced different materials by using different machines, and using a long production line it uses many tools. However, in 3D printing, it can produce different kinds of objects in different materials, all from the same machine. And it can also replace traditional factory production lines with a single machine. The benefits of 3D printing is that it can speed time to market. It can reduce development cost. For example, it can cut traditional tooling cost. And it can also increase innovation and personalized product. Next, Angela and Joe is going to talk about the human elements and the business applications.
This is Colton. He was born with unilateral cleft lip and palate. He had a 13-centimeter gap between his gums, half of his hard palate, and no soft palate. He now has a team of 9 specialists to manage his condition and outcome, and that's just at the hospital level. That doesn't include his team at school. At 3 months old, Colton had his very first surgery. His lip repair lasted 4 excruciating hours, but he came out looking like a different kid. Warning, the next picture is a bit graphic. Palate repair is accomplished by stretching and resectioning any tissue the surgeon can get their hands on. This is usually done at 1 year old. During the surgery, they put a stitch through his tongue to keep it out of the way, and he had to wear arm restraints to keep his hand out of his mouth. After this surgery, there are several years in which he just has to be checked every year to make sure he's progressing well. But that doesn't happen all the time. His head outgrew his palate, and he needed a palate lengthening surgery at 2.5 years old. In this surgery, he gets casts to keep his hands out of his mouth instead of just restraints. In the future, assuming all goes well with his growth, he will need 3 more surgeries. The first one will be a bone graft at around 8 years old, where they will use his hip bone to bridge the gap in his gums. After that heals, and he has most of his adult teeth, he will get braces and a dental implant where his eye tooth should be. At 18, he will have a nose and lip refinement. The process of the palate closure can cause the face to grow asymmetrically. An implant would take away the need for several of the surgeries and lessen the possibility of asymmetrical growth.
In terms of business applications, there is a definite bottom line component. The U.S. market for CMF was valued at $960 million in 2014 and grew by 4.6%. Extrapolated out, the 2018 market is almost $1.2 billion. In 2014, standard plates and screws represented 70% of the market. By 2021, custom or patient-specific versions will represent 35% of that plate and screw segment. In 2017, Johnson & Johnson introduced the first FDA-approved 3D printed options for titanium implants and instruments. These titanium implants represent a significant advance. However, the large defects often encountered in CMF cases may be better served by custom implants, which eventually resorb and leave host bone in their stead. We would recommend Johnson & Johnson look at advances in biocompatible materials 3D printed to complement the portfolio. As evidenced by Angela's presentation, this is a technology which may benefit all stakeholders.